This is question 7. A 12 cm diameter circular plate is placed over a fixed bottom plate with a 1 mm gap between two plates filled with glycerine as shown in figure 6 here. Determine the torque required to rotate the circular plate slowly at 12 rpm. So means that in this question they use rpm to show the rotational speed instead of using the radian per second. Assume that the velocity distribution in the gap is linear and the shear stress on the edge of the rotating plate is negligible. So here you need to understand that. So the design of this is actually slightly similar with the cylinder. However, if there are no liquid inside this gap, so means that the idea for calculating the rotating cylinder cannot be used because the idea is totally different. So first we need to draw the velocity profile. So because this here is rotate at certain rpm, so mean the velocity profile will become like this. So this we have a 2 point here. So and then at this point the velocity is equal to 0 due to the no slip condition phenomenon, and we could draw the velocity profile as this one. Okay. So and then we need to evaluate the condition of torque here. So we found if we have 2 points, one at this point and one at this outer point. So we found that at the outer point here, this molecule or this point will travel further compared to the molecule that in this area. So means that the difference of R here is need to be take care. So means that we need to solve this problem by using the idea of integration. So we could solve this problem by start with the equation. So Q is equal to FR, so F is equal to tau A, so and then the tau is equal to mu du dy. So we substitute into this equation, we could develop this equation. So and then we replace the value of du here with R omega and then the value of dy with h, and then we replace the value of dA here according to this calculation with 2 pi r dr. Okay, so what is the idea of this one? Okay, for this one, so if we see our application here, so we have a circular disc. So this circular disc, okay, we could calculate the area A as pi r square. So and then if we differentiate it to dr, so we write dA over dr is equal to 2 pi r, and then for sure we could write this one, dA is equal to pi r dr. So the value of dA here is substitute into this one, so and then we could get this one. So and then I think you already know what to do. So we differentiate this term, so we have a dq here, so we integrate the dq, we get a q, and then we integrate all of these, so we could get the mu omega over h 2 pi r to the power of 4 over 4. So the limit of integration is from 0 to capital R.